You manage a local department for the census, responsible for measuring the population of each block in the city where you live. Even though you could do it yourself, for each of the last 5 years, you've tasked this job to your subordinate, Jim. What Jim gives you each year is a 2x4 array of his population estimates, where each element of the array represents a city block. After 5 years, you have a 5x2x4 array of population estimates called Jim, where IJK represents Jim's population estimate for block JK in year I. The thing is, you don't fully trust Jim's estimates because you see him spending an ungodly amount of time on Facebook. So each year, you go behind his back and measure the population of 2 city blocks. After 5 years, you have the following data. Blocks, a 5x2x2 array indicating which blocks you measured each year, where IJ gives the coordinates for the jth block you measured in year I, and pops, a corresponding 5x2 array with the population you measured for the jth block in year I. How many times was Jim's estimate at least 10% higher or lower than your estimate? So to make this more clear, these are Jim's population estimates. And so, for example, these are his estimates in the first year. These are his estimates in the second year, third year, and so on. And blocks and pops corresponds to your estimates. So for the first year, you measured these 2 city blocks, block 02 and block 13, and the population you came up with for this first block was 100. So your estimate of 100 corresponds to block 02, which corresponds to Jim's estimate of 92. And again, your goal is to determine how many times Jim's estimate was at least 10% higher or lower than your estimate. All right, here's the solution that I came up with. So let's go ahead and break it down. Now, our initial goal is to build a 5x2 array of Jim's estimates that correspond to our 5x2 array of estimates. But before we do that, let's reimagine the Jim array as a row of matrices, and we'll do the same thing with the blocks array. So if I want to subset the Jim array and get back a 5x2 array, I can do that by using 5x2 index arrays for the I, J, and K dimensions. So let's set up that framework. So here I'll say I equals, and then I'll pass in a list, and let's just initialize it with all of zeros. So we'll do 0, 0, and we'll do 5 copies of that. And then we'll do the same thing for J and K. So these are index arrays that we're going to pass into the Jim array like this to pick out the elements that we want to fetch. So I here represents the year of the population estimates. So looking back at our pops array, well, the first row should just be year 0, and then we're going to pick out year 1, year 2, year 3, and year 4. Now, the J index array here is going to correspond to the first column of each nested matrix in the blocks array. So the values we want for the first year are going to be 0 and 1. So we'll say 0, 1, and then in the second year, it's going to be 1, 0. The third year will be 0, 1, and then 1, 0 again, and then 0, 1. And then the K index is going to correspond to the second column of each nested matrix in the blocks array. So in this case, we're going to pass in 2, 3, two, 0, 0, 2, 1, 3, and 1, 0. Okay, so if we run this, we'll get back the corresponding population estimates that Jim got, which correspond to our population estimates. So how do we make this a little bit more dynamic? Well, let's focus on the J index array here. So what we're picking out with the J is we're picking out every matrix in the blocks array, every row of each matrix, but only the values in column 0. So we can replace this sort of hard-coded array with blocks, square brackets, colon, comma, 0. And then the K index array is nearly identical, except we're picking out the values in column 1. So that leaves us with the I index array. Now notice the duplicate columns here. So we can actually get rid of this second column. And what will happen internally when we do this index here is that I will broadcast to match the shape of J and K. Now, this array here we can represent with np.arange, open parenthesis 5, square brackets, colon, comma, none. So remember, np.arange is just a 1D array, 0, 1, 2, 3, 4, and then square brackets, colon, comma, none just promotes that from a 5-by array to a 5-by-1 array. Okay, so once again, we have Jim's estimates. Let's go ahead and assign that to a variable called Jim_pops. So from here, the rest is fairly straightforward. If we do pops minus Jim pops, we get the difference between our estimates and Jim's estimates. If we wrap that in np.abs, we get the absolute differences. We divide by pops and we get the percent differences, or absolute percent differences. We'll check greater than or equal to 0.10 to determine which of them is at least 10% different. And then we can sum the true elements with np.sum and determine that 2 of Jim's estimates are at least 10% different than our own estimates.